Okay, so on Friday, and my sincere apologies that I forgot to video Friday's lesson. Well, I didn't forget to video, I forgot to bring the camera. We looked at using logs to solve equations of this sort. The log rules, that they are asked as questions on their own, but really logs are used in problems like this, where the missing value is in the power. And we looked at a couple of ways of doing it. So if you've done log to the base 7 of both sides here, absolutely brilliant. I'm going to do my log to the base 10 method, but that's not the only way. So I'm going to do just log of both sides of the equation. And the good news here is that the log of 100 is 2, because when there's no base, that defaults to base 10. I'm going to leave it as the log of 100, but some of you may have noticed that that's 2 and have replaced it with 2 straight away. But the real magic here is that we can now use the third log rule to rewrite that side like that. And therefore, 2x plus 1 is the log of 100 divided by the log of 7. So I'm just going to type that into my calculator using the LOG button on the calculator. Log of 100, which as I said, we already know is 2 over 7. Give me a horrible decimal number. That's what 2x plus 1 is. So I'm going to take away 1 and I'm going to divide it by 2. So we can now solve problems of the sort that we sort of started this log journey with, where you've got missing values in the power. Here, my LOG log approach probably is the best for here, but you might have done it with log to the base 3, I don't know. We can then use that third, so logging both sides of an equation is just now one of those things we can do, just like squaring both sides of an equation or adding something to both sides of an equation. I'm now going to use the third log rule on both sides. And then we just got one of those fantastic little bits of maths that I just love. This is why I love the subject I teach, because I've got x twice in that equation, and magically we're going to make it go to just once. So I'm going to multiply out that bracket. I'm then going to collect everything with an x on one side. And move that, because it hasn't got an x, onto the other side. And then here's the magic, isn't it? I'm going to factorise that side. So we go from 2 x's to 1x, and I've run out of space, but what I then do is just divide both sides by that. So I end up with x is equal to minus the log of 3. I'm going to type this in. Minus the log of 3, and that's divided by the log of 3 minus the log of 5. And that gives me 2.15. So that was solving equations using logs, part 1, where we started outside the bucket. And we jumped into logland by logging both sides of our equation. There are 2 more steps that we want to go through today. So here is an example of an equation we can solve using step 2, or type 2, because if you look at this equation, the left-hand side is already in logland and the right-hand side isn't. We're half in, half out. Okay? Half in, half out. So how are we going to deal with this? Well, the first thing I am going to do, and I invite you to do the same, is I'm going to use my log rules to make the left-hand side into a single log. So I'm going to use the third log rule to rewrite that as log to the base 10 of something, and then I'm going to combine the two using the first log rule. So just see if you can do that bit for me. Ignore the 2 on the right hand side. Just see if you can write the left hand side as a single log. Smells like baby ticks. And typing in the total's going to melt. That means big time. So I rewrote 2 log x as the log of x squared. That's doing the reverse to what we were doing a minute ago. A minute ago we were getting rid of a power by moving it to the front of the log. Now we're making a power by moving it from the front of a log. So that's a really key thing to understand. And listen, I'm fully expecting you to find this really tricky because it's tough to get your head around. This can be written as that. And then you've got the log of one thing added to the log of another thing. So my first log rule told me that was the log of those 2 things multiplied together. Right, I'm half in, half out. So I can't log both sides because one side's already logged. So what we're going to do is this. We're going to unlog. We're going to do whatever I need to do to turn that into 4x squared. And understanding what we need to do to unlog is the key to today's lesson. So let's take you right back to the very start of our log journey, just a few lessons ago. It seems like a long time. When I do log to the base 10 of that number there, I'm asking, what power of 10 is this? The reverse process, therefore, is doing 10 to the power of this. So if I take log to the base 10 of 4x squared and do 10 to the power of it, it kills the log. Why 10? Well, because that's the base. So to undo logging, we do that to the power of, and on that side it just kills the log, just gets rid of the log. But we know that when we do something to one side of an equation, we have to do the same to the other side. So I need to do 10 to the power of this side as well. And 10 to the power of 2 is 100. So to undo log to the base 10, you do 10 to the power of. That's the same as killing a fraction where the denominator is 3 by multiplying by 3. It's the same as square rooting to undo squaring. It's the same as taking away 3 to undo adding 3. To undo logging, you do a power. So when you do 10 to the power of that, you just get 4x squared. 10 to the power of 2 is 100. And yeah, the rest is easy peasy. A single log, and then I unlogged. Let's look at a second example. Sorry, the smartboard isn't working anything. So do that first step for me again. Just take that left-hand side and rewrite it. It's easier this time. It's the log of something, take away the log of something else. See if you can look back in your notes to remind yourself what the second log rule says I can rewrite that as. So I've used the second log rule just to write that as the log of something divided by something else, okay? Right, that's your choice then, okay? That's your choice. You shouldn't be using these toilets, you should be using this at Christmas toilets. I've told you, you're all new. Right, okay. 1, 2, 3, 4, let's say so I've written it as a single log, so now I'm going to unlog it. It's log to the base 3, so I'm going to do 3 to the power of both sides. Now, don't need to draw these little arrows, I'm just doing it while we're... So that on this side gives you that. That just gets rid of the log. 3 to the power of 2 is 9. Yes?
It's 11.
Oh, sorry. Well,
X plus 1.
oh, sorry. Thank you. Thank you. Thank you. Sorry. No biscuits today, but remind me when you're back in running. Now, kill the fraction. Multiply both sides by x minus 5 and see if you can bring that one home. It's another one where you've got x's on both sides, so get all the x's on one side, see if you can solve it. So I took away an x and I added 45, divided by 8. There we go. Now there's a disappointing lack of practice in the book. So there's just one question that's got a couple of examples, and I think that will be enough, to be honest. So I won't get the books out. Have a go at those 4 for me. So this, for those at home, this is on page 324, the top of page 324, question 4. Page 324, question 4. I'll come back in a minute with the answer. Right. So A and B, hopefully straightforward. Well, I still want to make a mistake. So for C, I moved that log over and then combined it all into a single log. So don't unlog until you've got that single log on either the left or the right hand side. I then undid the logging by doing 5 to the power of both sides, multiplied by 6, and if you worked out what the square root of 30 is and rounded it, that's fine. With D, so you can use the third log rule with both of those, and then I'm going to take away the one from the right hand side. So I end up with the log 9 of x plus 1 squared minus log to the base 9 of 2x minus 3 squared equals 1. So I've done a couple of steps in one go there. I'm then going to combine them into a single log, which I guess I could write as the whole fraction squared. And then I'm going to do 9 to the power of both sides. And then it was a bit fiddly, that one, but yeah, multiply everything out. You end up with a quadratic to solve, and of course your calculator will solve that. So you may choose to make a note of the answer and barrel on with that one. Okay, so that's type 2, where we've got half in and half out. So you might be able to guess what type 3 is. So we've had equations where everything's out of the bucket, no logs at all, but we've used logs to solve it. Equations where we've got half in and half out. So type 3 is all in, all in. And if you have a look at the sheet I've given out, you go right down to question 7 on that sheet. Question 7. I've got a copy of it here, so for those of you at home, I will attach this sheet to the email where I send you the link to the video. And we're looking at question 7 at the bottom of that. So here we've got question 7. Everything's in. Everything's in. So the whole thing is logs. No numbers at all. Everything is logs. So how can you tell the difference between this type and the previous type? Well, the previous type, there was always something that wasn't logged. Now we've got everything logged. But our method is almost exactly the same. I'm just going to change this slightly. Don't unlog until you have a single log on each side. So actually this is a little bit simpler because I can leave this as log 3 of 2x plus 3 and just combine these two using the first log rule. So we get, on the left-hand side, log to the base 3 of 5x, and on the right-hand side, log to the base 3 of 2x plus 3. I've got a single log on each side. Now, I can unlog. And it doesn't matter that I understand that to unlog I'm going to do 3 to the power of both sides, because I just get... Now, of course, this only works if you've got a log to the same base. You wouldn't get it where it wasn't. And then it's just really easy. So 3x equals 3, x equals 1. Now, in that question 7 on the sheet, there are 2 other examples of all in. Okay? I just want you to do those 2 examples. Can I tell you which ones they are? So, on that question 7, we've done part A. There are 2 other examples of equations where you have got everything in logs. And I just want you to have a go at those. Remember, this is easier, much easier than the middle set, because all I need to do is to get a single log on each side. I haven't got to move anything across sides. So see if you can look at question 7 and identify the 2 questions, the 2 remaining parts of question 7, which are of this type, all in. And I just want you to do those for me. So I hope you jumped to D. I haven't finished it yet, but I've rewritten both sides as a single log using the second log rule. I've then unlogged, because I can do that when I've got a single log on each side, and then it's just algebra, nothing to do with logs. So I killed the fractions, I multiplied by x, and I multiplied by x plus 2, did it both at the same time. So that just becomes x plus 2, and that becomes 5x squared. That stays as 5x squared, and that becomes x plus 6, x plus 2, then you just got to multiply that and solve it. Once you've done the other one, there's only 2 in that question which are of that sort, have a think about how you can approach 8a, which is a simultaneous equation problem. So with D, rule it out, rule it all over to one side. Use your calculator by all means. I like to keep my factorising skills fresh. So yeah, you get 3 and minus 1. And then here, probably an easier example, I used the third log rule on the left-hand side to write that as the log of x squared. First log rule over here, unlogged, shoved it all onto one side, and you get x is 5 as a repeated solution. Okay, so question 8 takes this a step further, really, and we're now sort of, we're now dealing with all 3 types. So we've got simultaneous equations to solve here, and we normally, when we solve simultaneous equations, if they're both written as y equals, we make them one equal to the other, or sometimes we can use a method of substitution, rewriting one equation as x equals and replacing x with that. We've got the added complication though here of logs. So any suggestion as to how I can start here? Callum, how could I make a start in this question?
Could you unlog the first one so you get y equals x squared?
Fantastic, yeah. Can you see here it's log to the base x. So I can unlog that by doing x to the power of both sides. So that just unlogs that, and I get that. I can then use substitution, y is equal to x squared, so in my second statement I can just replace that with x squared, so I get x cubed is 27, so x is equal to, not 9, sorry, 3, x is equal to 3. So do you want to have a go at the other one that's a bit like that is, what was the one that was a bit like that? D. Have a go at D. And then once you've had a go at D, have a little think about how you can approach B. I know we're doing it in a funny order, but I'm trying to sort of pick our way through it in a logical way. So we're on question 8 now. I've done A there. Have a look at D, which is very similar, and then see if you can get somewhere with B. B is a slightly harder example. So with D, we unlog the first statement by doing y to the power of both sides, and that gives me an x equals statement, so I can replace that x with y to the power of 3 over 2. It's not x on its own though, it's x to the power of 3, so when you've got something to the power of 3 over 2, sorry, to the power of a third, when you've got this here, we just multiply the two powers, and 3 over 2 times 1/3 becomes 3 over 6, which is a half. So that becomes just that. So you've got the square root of y plus 3 square roots of y. That's going to give us 4 square roots of y. So that means that the square root of y must be 5. So y is 25. I've just realised that in the first example, I didn't go on and work out what y was. Simultaneous equations, there are going to be two answers. So in part A, having worked out that x was 3, y is equal to x squared. And similarly in this one, x is y to the power of 3 over 2, which is the square root cubed. So that's 125, although your calculator would do that for you. So last one we do today, with question B, get the log x on its own and move the log y onto the right hand side and combine it with the log 2 into a single log. Then you can unlog both sides and you'll get an expression that says you something about x and y. So with this one here, leave that where it is, but move that over onto the other side and use your log rules to write it as a single log. Okay? And if you've done that one, I want to have a go at C, it's a similar thing. Let's get our log of x on one side and our log of y on another side. Actually, this too could come over here, and we could, but I'm going to leave it where it is. So I'm just going to have x's on one side, y's on the other side. Right, so I moved the this across, I added it to both sides. I then combined it into a single log. I did that in one go. I don't know if you're at that point now, so I wrote that as log to base 5 of y squared multiplied it by 2. Now I can unlog. So I can then substitute that into the second equation. X plus y squared is 12, but x is 2y squared. So you get, so 3y squared is 12. So y squared is 4, so y is plus or minus 4. C was a little bit more fiddly because of the 3. It was a half in, half out. So with C, you needed to add the log 2 log 2y to the other side. So and then you had to combine it into a single log. We'll do that one first thing tomorrow. See how we get on with that one.